So today we will be demonstrating Boyle's law with keeping temperature at a constant rate. So one inverse relationship is between pressure and volume to demonstrate with this cooking syringe. So, as for example, when pressure increases, volume decreases. Now, when pressure is decreased, volume inversely increases, like so.
Alright, so here we have Lussig's law. So Lussig's law basically states that there's a direct relationship between pressure and temperature. So over here what we have set up is we have a bowl filled with water, and then over here we have a Coke can that is heating up. So this Coke can currently has high temperature, which means that it also has high pressure. But once we bring it into the cold water, its temperature decreases. And because it's a direct relationship, its pressure also decreases. So as you can hear, the cold water basically gets sucked up into the Coca-Cola can. And this is because the temperature is decreasing in the can, because the pressure is also decreasing, it wants to stabilize itself because the pressure in the outside environment is different from the inside of the can. So it sucks up all the water in order to stabilize the pressure, and that is Lussig's law.
To test the effect temperature has on volume, I'm going to be putting this balloon glove into the freezer, and we'll see what it looks like in a few hours. Now that my balloon has been in the freezer for a couple hours, I'm going to take it out and see what it looks like. It's obviously a lot smaller, and this is because volume and temperature have a direct relationship. This can be explained by Charles' law, which states, well, that volume and temperature have a direct relationship. So while temperature will decrease, the atoms, or the gas molecules will settle, and they'll take up less space, and therefore less volume will be present in the balloon. Alright, now what I'm going to do is I'm going to boil some water, place the balloon in, and see how big it gets, and I'll explain why that happens. So, now that my balloon has been sitting in the hot water for quite some time, we can see that it's grown quite a bit. And again, this can be explained by Charles' law. Because the temperature increased, the volume of the balloon increased, and it's because the temperature of the molecules went up, so they moved farther away from each other, causing the balloon to expand and creating the larger volume that you see right here.
Some units of temperature used in gas laws are degrees Celsius, degrees Fahrenheit, and Kelvin, which is degrees Celsius plus 273, and some units used of pressure in gas laws are mmHg, atm, and kPa. The pressure of a gas is the force that a gas exerts on the walls of its container, which leads me to the mathematical equation of pressure equals force divided by area, which is from the force exerted of the gas divided by the area of the container. And the picture that I have here is showing particles of a gas moving along in a container and hitting the walls, and as it hits the walls, more and more pressure is formed